right, so I'm going to walk you through all of the graphing that you need to do for this lab. And so ultimately, the purpose of this entire lab is for you to determine the order for the reaction of crystal violet with hydroxide. So looking at how the concentration of crystal violet changes over time, creating your three different graphs to determine if it's zero order, first order, or second order. But in order to do that, what you first have to do is you have to be able to relate absorbance to concentration, because what you're going to be measuring every 20 seconds is absorbance, but what we care about is concentration. And so the first thing that you're going to do is, I've already written in my data right here. Here are my concentrations, the different concentrations that you created, and these are the absorbances that I measured when I did it myself. And so what I'm going to do is I'm going to create a Beer's Law graph. And so I'm going to go to Insert. I'm going to create a scatter plot. Okay? And this shows the relationship between concentration and absorbance. Now this might be different for everyone's computer, but if you look on the left-hand side here for mine, I can add my axes. So I'm going to add a horizontal, and I'm going to add a vertical as well. Okay, so my x-axis is my concentration. So I'm going to write concentration, and it's in micromolar. Okay, then I'm going to plug in absorbance on my y-axis. Okay, and there are no units for that, so I'm good. Now I need to create my trend line. Okay, so I'm going to add a chart element. I'm going to add a trend line, and I'm going to add a linear trend line. Now there's a clear trend line here, but what I care about is actually having a formula to relate concentration and absorbance. So I'm going to go in, and I'm going to add more trend line options, and right here it says display equation on the chart. Okay, so here's my equation that I've got. Okay, that relates y, which is your absorbance, and your concentration, which is your x. Okay, so I'm going to use that extensively in just 1 second. Really quickly, I'm going to write my title, which will be absorbance versus concentration. Or you could say how concentration changes with absorbance, or how absorbance changes with the concentration, whatever you want. All right, now what I'm going to do, at this point in the lab, you then created your reaction. You added 4 mils of your crystal violet solution and 4 mils of your hydroxide, and then you measured the change in concentration every 20 seconds. So I've now pasted all of my absorbances for the 10 minutes that I recorded it myself. These are the absorbances that I got. And so what I'm going to show you really quickly, I'm going to show you a number of shortcuts that you can do in Excel to make your life a lot easier. So I want on my x-axis, I'm going to put it right here, my x-axis is going to be my time. So I know I want every 20 seconds. Okay? So as soon as I create 3 of these, please do not type out the rest of it. That would be a waste of your time. Instead, what you're going to do is you're going to select those 3, and then if you notice the little cross right there, if you just pull down until you hit your last time, there is 600 seconds. So Excel is able to see a pattern and then create an infinite number of cells with that pattern, which is really nice for us. So I already took care of time. Awesome. Now, what you would have to do if you didn't have Excel is you would have to take each of these absorbances, plug it into your y right here, and solve for x, which I think is a huge waste of time. So instead, what I'm going to do is I'm going to create an equation. So to create an equation in Excel, you start off with equals. Then I'm going to take my absorbance, okay, which is right here. Okay, I'm going to add to that 0.0129, because remember I'm solving for x, my concentration. So I'm going to add 0.0129, okay, and then I'm going to actually put all of this in parentheses, because what I'm going to do then is I'm just going to divide by 0.0376, right? That's how you get x. If I were just to solve this one, I would take 0.455, add 0.0129 to it, and then I would divide all of that by 0.036. So I've created an equation for it now. Okay? Awesome. There is my concentration. Now here's the really cool thing. I do not have to type this in for all of these values. Instead, if you just select this and have that little cross, if you go all the way down to 600 seconds, it calculates it for you. And here's how. What it's doing, if you look at the equation right here, it's taking the absorbance at N31, which is this one right here, so this absorbance, which we want to use, it's adding the 0.0129 to it and then dividing by 0.0376, which is exactly what we want. Okay, so that's my concentration. So I've got time versus concentration, which is awesome. So I'm going to create one graph with that in 1 second. First, what I'm going to do though is I'm going to prepare to make my other graph. So I'm going to select all of this, I'm going to copy it up, and I'm going to put it in right here. Okay, now for my second graph, I want the natural log of these concentrations. So I'm going to hit equals ln, and it has the natural log function, and then I'm just going to click that concentration right there. Okay. Now, so that I get all of the natural log concentrations, I'm just going to scroll all the way down to 600, and there you go. Finally, I'm going to take my times, and the last one that I have to do to see if it's second order is do 1 over the concentration. So I'm going to hit equals 1 over, and then I'm going to select my concentration right there. I'm going to hit enter, and now I've got my values for 1 over concentration. And it's as easy as that. So you don't have to plug every single value in because that would be a huge waste of time. So now what I'm going to do is I'm going to take my time versus concentration, that's my first one, and I'm going to make my graph. So I'm going to insert, I'm going to do a scatter plot. Okay, there's my chart right there. Okay, again, remember you need your y-x axis. So horizontal for my x, add a y-axis. Okay, so this is going to be concentration in micromolar. Okay, that's my y-axis, and then this is going to be time in seconds. Okay, and then I can do concentration for my title, concentration versus time. And remember, you see a little bit of a curve here. It's not totally obvious. Maybe if there, you can see a little bit more of the curve. This is curved, which tells me that it's not going to be 0 order because it's curved. And in fact, it kind of looks like it's going to be first, but let's see. So in order for it to be first order, I'm going to select my time versus ln of concentration. I'm going to create another scatter plot. Okay, and this one is much more linear, which tells me since ln of my concentration is linear with a negative slope that this is going to be first order. But let's make sure we got everything plugged in here. Okay, so this is going to be ln of my concentration. Okay, I can do it like that, or I can hit to actually type out concentration. For this one, that's going to be time in seconds, okay? And this is going to be ln of concentration versus time, okay? Now, the cool thing that you can do, because you will need to do it, to get your equation, your trend line, let's say, for example, I want the trend line for this one. Remember, you're going to hit add trend line, and we want it to be linear. Okay, and then we're going to go in here and we're going to have our equation show. Okay, so looking at that, based on my data, my K value, my pseudo constant, rate constant, would be 0.0015 because this is first order. Now you need to create your second order graph, the 1 over, just to make sure that the reaction is not second order, but it shouldn't be. It should be first order. Okay, really quickly, what I can do here to show that this is a curve, I can add a trend line, and I'm going to show an exponential trend line. And if you notice, it's not linear. Look how perfectly it fits my data. So that demonstrates to me that this is not linear, my concentration versus time, and therefore that proves that it is first order because my natural log graph is linear with a negative slope. Okay, so those are just some cheats and some explanations